Okay, in this video, I want to go over how to find a solution of a system of three variables equations with these three examples. Now, the solution of a 3D three-variable equation system is similar to the two-variable one. It is basically just a point of intersection of three straight lines on a 3D graph. So how do we find a solution of the three-variable system of equation? The first step is we want to come up with a system of two variable equations. And the way we do that is we want to pick two out of these three equations in example 1 here, and we eliminate one of the three variables, either x, y, or z. And then we go back, pick two more, and eliminate that same variable. After that, we are going to group the two new equations, which now have only two variables, either x and y, x and z, or y and z. And then from there, it will become a two-variable system of equation where we get to use either elimination, substitution, or graphing, just like I showed in the previous examples. So let's label this equation as capital A, this is capital B, and this is capital C. Now, looking at these three equations, it seems like I can go ahead and eliminate the variable z, because if I compare the equation A and B, well, looking at the variable z in equations A and B, I have minus z and I have plus z. So mentally, if I add them vertically, the z will cancel out. So in this case, I'm going to go ahead and eliminate the variable z to come up with the first two variable equation. So select A and B is what I'm going to name this step. What am I going to have? Well, I'm basically going to bring them over. I'm going to bring 2x plus y minus z equal 5. And then now at this step, I'm adding equations A and B vertically. Well, if I add them vertically, the two z cancel out, so minus z plus z cancel each other out. 2x plus 3x is going to give us 5x. Y minus 2y is going to be minus y. 5 plus 16 is going to be 21. So this is a new equation which only has two variables, x and y, namely. So I'm going to name this equation by capital D. Now let's go back and pick two other equations out of these three originals one and eliminate that same variable z. So I already picked A and B, so now I'm either selecting A and C or B and C. Well, I'm going to select B and C to come up with the new two variable equation, because when I compare the z variables, I get a plus z and I get a minus right here. So if I can somehow convert this z into the plus 5z, then when I add equations B and C vertically, the plus 5z and the minus 5z will cancel out. So the next step is I'm going to select, I'm right over here. Yeah, you can see that. So this step is select B and C. So B is 3x minus 2y plus z equal to 16. And then C is 4x plus 3y minus 5z equal to 3. So to cancel out the z, like I said, I have to somehow convert. I have to somehow make sure that this z term and this z term are the opposite of each other. Well, with the invisible coefficient 1 in front of the plus z, I can easily convert the plus 1z into plus 5z if I multiply the entire equation b by 5. So that will give me what? Well, that will give me, let's see, distributing the 5 into every term of the b equation. I'm going to have 15x minus 10y, and then plus 5z equals to 80. And then for the c equation, I keep it the same. So this is 4x plus 3y minus 5z equals to 3. Okay, let's double check the work. Yeah. Now, when I add these two equations vertically, again, plus 5z minus 5z cancel out, and 15x plus 4x is going to be 19x. Negative 10y plus 3y is going to be minus 7y. Equal 80 plus 3 is 83. So I'm going to name this equation E. Now we get equation D, only two variables x and y, and then we get equation E with only two variables x and y. Now we group them together. So we're going to group 5x minus y and 19x minus 7y. Oops. And then equal to 21 and 83. So just like in the videos where I do examples of two variable system of equation, or I mean system of linear equations, at this step I get to use either substitution, elimination, or graphing. Well, in this case, I'm going to do substitution because, I had a minus y here. If I add y to both sides and then subtract 21 to the other, I would have something equals to y. And then I can take that something and plug it back into, plug it into the y of the other equation here. So this is D and this is E. So for this one, I'm going to add y to both sides for equation D, and I'm subtract 21 at the same time. So these two cancel out, these two cancel out. My new D equation is now going to be 5x minus 21 equals to y. Well, guess what? Y equals something. This is a something that I wanna get in order to substitute this something into the E equation. So that means my E equation now is gonna be 19 times x minus 7 multiplied by 5x minus 21 and then equal to 83. But hey, let's see, distributing the negative 7, I would have 19x minus 35x plus, let's see, 147, my bad, equal 83. Combining like terms, 19x minus 35x is going to be negative 16x. Bring down the plus 147 equal to 83. Subtract 147 to both sides. We got 16 times x equals to, let's see, 7 minus 3, that's 4. 14 minus 8, that's 6. And then this is going to be negative 64. So divide both sides by negative 16. I get x equal positive 4. Yeah. Now with x equals to positive 4, all I have to do now is that you go backward. So with one variable known, going backward to find the second one, which is the y, namely, and then take the x and y, plug it back into one of the three original equations to find the last one, which is the z. So if x equals to 4, what am I going to have? Well, that means I'm going to have 5 times 4 minus 21 equals to y. When I take the x equals 4 and I plug it back into this blue y equation here. So let's see. Mental math, 5 times 4, 20. 20 minus 21 is going to be negative 1. So y equals to negative 1. With x equal 4 and y equals to negative 1, select either A, B, or C and plug in x and y to solve for z. I'm going to select B because I get a plus 0 here, so that makes it a little easier. So choose B. b in this case. So b is 3x minus 2y plus z equal to 16. But we know x is 4, so we got 3 times 4 minus 2 times y is negative 1, so minus 2 times negative 1. Keep the plus z and keep the equals 16. Well, at this step, we know 3 times 4 is 12. Negative 2 times negative 1 is positive 2, so 12 plus 2. This is 14 plus z equal to 16. Subtract 14 to both sides. I got z equal to 2, and I don't know why I crossed this out. It's supposed to be there. So I got z equal to 2. So the solution of this system is x comma y comma z, which is 4 comma negative 1 comma 2.